Sound is more than vibration. It carries quantum information, influences cognition, and interacts with electromagnetic fields. New research reveals that sound waves shape quantum behavior at the phonon level, creating structured resonance patterns that may synchronize with neural activity. The mind doesn't operate in isolation. Neurons generate electromagnetic waves, producing biophotons that interact with external frequencies. If thought follows electromagnetic resonance, then sound functions as a tuning mechanism, aligning cognition with structured quantum fields. Acoustic waves control charge carrier transport in semiconductor nanostructures, demonstrating that sound manipulates quantum states at the particle level. Phonons, the quantum unit of vibration, exhibit interference patterns similar to photons, reinforcing the idea that sound waves influence subatomic processes just as light does. In biological systems, phonon-based interactions guide vocalization, cognition, and sensory perception. The quantum vocal theory of sound suggests that phonation, turbulence, and supraglottal vibrations exist in superpositions of states, shifting between harmonics that align with electromagnetic structures. This means that voice, thought, and external frequencies operate within a shared quantum framework. When sound reaches the brain, it does more than stimulate hearing. It entrains neural oscillations, altering perception, modulating consciousness, and potentially aligning with external quantum fields. Experiments have shown that phonons can function as quantum information carriers, opening a new possibility for sound-driven cognitive enhancement. This research transforms our understanding of thought, memory, and communication. If sound encodes quantum information, then specific frequencies could amplify cognition, unlock deeper awareness, and synchronize the mind with quantum structures of reality. Light is structured information, quantum energy, and the foundation of perception itself. At its core, light operates as both wave and particle, interacting with reality through coherence, entanglement, and angular momentum. New research reveals that its quantum properties extend far beyond classical physics, shaping how information moves, how matter forms, and how consciousness interacts with the field. Photons, the quantum units of light, carry orbital angular momentum, encoding data within their spin and motion. Structured light enhances this effect, increasing information capacity of individual photons and revealing deeper connections between light and quantum computing. Quantum electrodynamics shows that light's coherence is influenced by emitting particles' momentum uncertainty, meaning that its wave function is more than just an energy signature. It carries structural imprints of the source itself. In biological system, light plays a direct role in cognition. The brain emits biophotons, weak flashes of light generated by neural activity. These emissions correlate with thought processes, suggesting that cognition itself may operate through structured interaction with electromagnetic fields. If light encodes information at the quantum level, then every photon the brain emits carries a resonance pattern that may extend beyond the body, interacting with external fields in ways we are only beginning to measure. Quantum optics also reveal new methods of manipulating light to harness information-rich structures. High-dimensional photon states allow entangled light to store and transmit data beyond traditional binary limits. By tuning coherence and wavefronts, structured light fields open pathways for quantum communication, advanced computing, and interactions with fundamental space-time geometry. Light is more than what we see. It's a multi-dimensional frequency structure encoding reality itself. Thought, perception, and existence are all linked to the way light moves, interacts, and informs the world. Understanding its quantum structure opens the door to unlocking higher states of awareness, new forms of technology, and deeper insights into the very nature of reality. Light and sound are more than sensory experiences. They are quantum forces that shape reality. New research reveals that sound waves can tune single photon sources, directly influencing the quantum properties of light. This discovery bridges two fundamental forces, revealing a new layer of physics where vibration and light interact at the quantum level. In this experiment, researchers used acoustic waves to control charge carriers in semiconductor nanostructures. This technique allowed them to manipulate single photon emissions with extreme precision, proving that sound can influence quantum light sources at a fundamental level. The ability to tune light with sound creates new possibilities for quantum information processing, advanced optical technologies, and deeper integration between wave-based physics. Phonons, the quantum units of sound, behave like bosonic particles, just like photons. The study demonstrated that phonons exhibit Hong-Yu-Mandel interference, proving their quantum nature and showing that sound can be entangled much like light. If sound and light operate within the same quantum framework, And frequency manipulation extends beyond optics, opening doors to new methods of controlling quantum states using acoustic resonance. This research carries profound implications for quantum computing, secure communication, and biological information processing. If light encodes quantum data and sound can tune its properties, then cognition itself, a process driven by electromagnetic and vibrational signals, may operate within the same quantum field. By harnessing the quantum connections between sound and light, we gain access to a new form of control over reality itself, a tuning system where vibration and photons synchronize, unlocking dimensions of technology, consciousness, and fundamental physics.